Welcome back. Why is time important in space flight calculations? Here are some reasons. 1. All initial state vectors or orbital elements must be associated with a time of observation known as the epoch. 2. You must know where the Sun and Moon are located relative to Earth. 3. You must precisely know the rotation of Earth relative to the x-axis of the ECI coordinate system. 4. A precise time source must be available for space navigation purposes. It is used to integrate measured acceleration to find velocity and position. In this video, I describe the difference between a solar day and a sidereal day, and then show you how to calculate the rotation angle of Earth based on calendar day and time. A solar day is 24 hours long. This is the time required for the Sun to reappear above the same Earth latitude each day. It is not the time required for Earth to rotate once in inertial space. A sidereal day is the time required for Earth to rotate once, or 360 degrees, in inertial space. It is 23 hours, 56 minutes, and 4.0905 seconds long. I demonstrate this in the image on my right, where you can easily see that a sidereal day is shorter than a solar day. In fact, a solar day is 1.0027378 times the length of a sidereal day. Greenwich Sidereal Time, or GST measured in degrees, is the angle between the prime meridian, or 0 degrees longitude, and the direction of the vernal equinox. What we need is an equation that defines this angle as a function of coordinated universal time. We can record the universal time, UTC, and date when GST is equal to 0 degrees, and then use this to calculate a reference day number, D0, which includes both an integer and a fractional part. I show this calculation in the equation to my right, where MJD is the modified Julian day and represents the integer part of D0. The fractional part of D0 is shown in brackets. In this equation, UTC.H is coordinated universal time hours, UTC.M is coordinated universal time minutes, and UTC.S is coordinated universal time seconds. The next equation can be used for calculating the integer modified Julian day based on calendar date. In this equation, remainders must be ignored when dividing. It is valid from March 1900 to February 2100. Also, in this equation, Y is all 4 digits of the year, M is the month number, 1 through 12, and D is the day of the month. On July 9th, 2021, Greenwich Sidereal Time was equal to 0 at 4 hours, 50 minutes, and 34.8 seconds Coordinated Universal Time. Therefore, based on the two previous equations, our reference day number, D0, is equal to 7,861.2017966, and is the day number when a line from the Earth's center to the prime meridian was in the direction of the vernal equinox. Now we can calculate the angle for how far Earth has rotated since D0 using the next equation I show. In this equation, 1.0027371 multiplied by 360 is the length of a solar day in degrees, and D1 is a different day number. Since our reference day number occurred when GST was 0, this angle is the Greenwich Sidereal Time measured in degrees for the day number represented by D1. Typically, this is normalized to 360 degrees, so it is always between 0 and 360. To calculate the current Greenwich Sidereal Time in degrees, simply find D1 for the current time using the first equation, and then insert this value into the last equation. It's that easy. If you find this video useful, please give it a like. If you find this channel useful and want to be notified when we add more videos, click on the notification bell. Finally, leave a note if you have comments or recommendations for new videos. Goodbye.